Hey everybody, Mr. Mac here. I would like to go over some selected solutions for the 3.1 and 3.2 practice set. We already did these first few in class already, so I think, how about we take a look at 20? Let's do 20. We have this quadrilateral here, and we know we've got some stuff that's parallel. So these lines here or segments are parallel, and then these match with this. So let's talk about some relationships here. This angle and this angle are on alternate sides of this transversal. These are my parallel lines here, right? And so these two angles are interior of the parallel lines, and they're on alternate sides of the transversal. So these are alternate interior angles. And if we have parallel lines, alternate interior angles are congruent. So that means 2x equals 42. Divide both sides by 2, x equals 21. So that's our solution for x. Now, if we're looking at these two angles here, let's now work in eggplant. That's the color. These two angles are on the same side of, now this is the transversal, just say T. This is the transversal, and these are the parallel lines that we're looking at. So we have a different perspective, we have different transversals and different lines. Same side of the transversal and interior of the parallel lines. This is same side interior, and same side interior angles. And same side interior angles are supplementary. And the way we can remember this, if we can't remember this, is the S's. Same side supplementary, the 3 S's. Okay, what supplementary mean? Means that it adds to 180. So let's take this angle and add it to this angle and set it equal to 180. Well, we already know that this angle is 42. So I really don't even have to write the 2x. I just could have gone right to writing this as 42. 8y plus 44 equals 180. Subtract 44 to both sides. And what is 180 minus 44? It is 136 on most days. And now we can divide by 8. And does 8 go into 136? And subtract 17. So y, and it just, there you go. Just kind of died on me there for a hot second. Y is 17. Okay, so that's 20. Let's have a look at, so I think we did 21 already. Just to quickly review, measure of angle 1 and 8. These angles here are alternate exterior angles, or alternate sides of the transversal, and they're exterior of our parallel lines. These are congruent. And so that means I can set these two expressions equal. So 4x plus 35 equals 7x minus 40. And this is kind of bugging out on me here. So I can subtract 4x over here. Might as well just do it now. Guess I'll just do it. 35 equals 3x minus 40. Now I can add 40. Come on. 3x equals 75. If I divide 75 into thirds, that gives me 25, doesn't it? It's 25. Okay, and then if I put it in there, 4 times 25 is 100 plus 35. This would actually be 135 degrees if we were trying to get the angle. Let's take a look at this next one here. 2 and 7. 2 and 7. Well, these are actually also alternate exterior angles, just on the other side. So they're equal. Alternate exterior angles are congruent, so I can say 2y squared plus 2 equals 8y plus 12. I have a power of 2 and a power of 1 here. I'm not going to be able to solve this as a linear equation. This is a quadratic, so I need to put this in standard form. Standard form is ax squared plus bx plus c equals 0. And then we can factor this trinomial into a binomial and use the multiplicative property of 0 to get our two answers, our roots for the equation. So let's bring over the 8y by subtracting it. So I just subtracted that, bring it over the left side, and let's bring the 12 over by subtracting it as well. So everything has been brought over. So the right side is 0. Let's combine these terms. Two minus 12 is negative 10. Notice that every term in here is even. That means we can divide everything by 2. And that's going to give me, let's get rid of this right here. We're not going to do that one. That's not factorable anyway. We need to use the quadratic formula for that one. So we'll look at that later. Well, this one is doable. So we are going to factor this into two binomials where the first term has to be of each binomial y, because y times y is y squared. And the second term of each has to be a factor of negative 5. So we are looking for the factors, that's an A, of negative 5 that are going to add to get this middle term here of negative 4. So 1 and negative 5 and negative 1 and 5. Those are the only factors of negative 5. So which one of this gives us negative 4? It's this first one. The second one here will give us positive 4. It's got to be negative. So that's going to be y minus 5, y plus 1. So let's take this, each one of these binomials, and set it equal to 0. And then solve. I want this to be 0 because 0 times anything is 0. This is the multiplicative property of 0. So it's just simply 5 and negative 1. Negative 1 in here will work. So there's two possible solutions that will work. So we're going to keep them both. And that's it. And let's take a look at this one. 32, I like this. This is a little puzzly. Like puzzles, like games. Have a whole bunch of lines here with some givens, some parallel lines here, and some transversals. So we know this is 78 right here. So Angle 1 and angle 78 right here. These, oh, it's a linear pair. This is supplementary right here. So what plus 78 is 180? That's 102. So measure of angle 1 is 102. 7 and angle 1, this is a vertical pair of angles. So 7 is 102. So measure of angle 7 is 102. Let's see. How about we go over this way? 4 and 78. Corresponding angles. Corresponding angles are congruent. So this is 78. Well, 4 and 6 are corresponding angles. Measure of angle 6 is 78. So let's keep on bringing this down. This angle here is 78. That means angle 2 is 78. Angle 2 and angle 6 are actually alternate exterior angles, or I could say that these are vertical angles. Just solving the puzzle. What we got? 3 corresponds with 102, or is a linear pair with 78. So measure of angle 3 is 102. Notice a lot of 102s and 78s here. We're going to wreck that here in a second because angle 5 is coming off a different transversal right here. Look at this. There's some sound effects for you. So 5 is alternate interior with this 22 down here. Look at that. If you get rid of all this junk, you'll see these parallel lines, and that's a transversal. 5 is 22. And is there an 8? Nope. That's it. So that one's done. So for 33, let's just do this last one. Y squared plus y minus 1 is linear pair with 7x minus 15. 7x minus 15 angle is alternate exterior with the 4x plus 45. So before we can write an equation with y, we have to find x here, and we can. We know that alternate exterior angles are congruent. So I can take 7x minus 15 and set it equal to 4x plus 45. Subtract and add 15. 3x equals 60. X equals 20. Divide by 3. X equals 20. So let's put 20 in for x here so we can get an angle. So 7 times 20 is 140 minus 15. Okay, so this angle right here is going to be 7 times 20 minus 15. 140 minus 15 is 125. So this angle is 125 degrees. Now, we have to find y. So I'm just going to erase this one. I'm not going to do this one. You do this one on your own. That one's a little bit easier anyway, I think. So y squared plus y minus 1. So I just said is a linear pair with the 125. So if we add them, they're supplementary. So they should be equal to 180. So the y squared plus y plus 124 And this is a quadratic, so we can't, this is not a linear equation. You can't just solve for y here with a linear strategy. So we have to put this in standard form again, like we did, and then we're going to factor. Okay, so subtract 180, and we get y squared plus y minus 56 equals 0, right? 124 minus 180 is negative 56. And then two binomials, factor two binomials. First term is going to be y and y. This term, we need to factor negative 56, so it adds to 1. That's a 1 right there in front of the y. So it adds to 1. So what are the factors of negative 56 that add to 1? We've got negative 1 and positive 56, but that doesn't add to 1. Negative 2 and 28, that doesn't work. 3 will go in, which won't work. Our values are going to be negative 7 and 8. Negative 7 times 8 is negative 56, and when I add these, I would get 1. So this is going to be how I factor. And we could check this. I mean, we can go y times y is y squared. That's first. Outer. Inner. That's an ugly y. Last. Negative 56. And then these added together give me the y. So I'm just checking it. And that works, right? Little Command Z action here. Let's back this up. So let's take this and set it equal to 0. Let's take this, set it equal to 0, and solve. Y is 7 or negative 8. Those are our values right there. And if I want to put these in here, 7 squared plus 7 minus 1, it should give me 56. If I put negative 8 in here, it's going to work too, because a negative 8 squared is 64. Minus 8 minus 1 is also going to give me 56. Okay, that's it. So some selected solutions there. Very good.